Thank you. Yeah, I'm Neil Ashworth. I'm a former Chief Petty Officer in the Royal Navy and a Royal Navy Commando. So I used to do, for 14 years, I did a job called SIGINT, Signals Intelligence, where it's effectively the interception and analysis, cryptography, cryptology, cryptanalysis of HF and VUHF signals, code breaking type stuff. I did it in the fleet for a number of years on both UK and US warships. Served on USS Emery S. Land, which was a helicopter landing ship off the coast of Africa for a number of months, basically just trying to track down any type of spurious activity from the Chinese. On that trip, I actually met Donald Rumsfeld, which was interesting because I had a big bushy beard at the time, and I got to speak to him about the intelligence collection efforts that were ongoing off the coast of Angola. Anyway, I moved around quite a bit, as you can imagine, as a communications technician, which was the job role. I had a plethora of jobs throughout the fleet across different services, and working quite considerably with US counterparts, especially when I worked as the head of operations at the Fleet Information Operations Center in the UK. So yeah, that was me. And about 6 years ago, I moved to America. I retired from the Navy and started working in InfoSec in the corporate world. And I can tell you it was quite a change. I initially began life at Ingram Micro, where I was doing PCI DSS compliance. That was a good compliance framework, I would say, to cut my teeth upon, because it did give me quite a good exposure to all the different facets of IT security. And for the last 2 years, I have been working at Nutanix as a security solutions architect. In that role, I help customers understand the benefits of our platform from a security perspective, and help deal with any questions that they might have with deployment, architecting for specific environments, and things of that nature. So the agenda won't make much sense, and I realize that now. I had to throw this together last night, but effectively, I'd like to speak briefly about the State of the Union. I know George covered some of that, but I'd like to highlight a couple of areas that, especially me in my role, working from a technology vendor, we are uniquely positioned to see emerging trends in data center security that exist in both private and hybrid cloud environments. So this is really where I'm kind of directing the agenda for this presentation. So the more things change, the more things stay the same. So as I said last night, I was putting this presentation together, and I decided to do a quick Google search with the term ransomware, that obviously being the prevailing malware type these days. And the top 3 news items being between 2 and 8 hours old. Diebold Nixdorf is a major provider of ATM machines and a payment technology to banks and retailers, and it's recently suffered a ransomware attack that disrupted their corporate network operations. Now, the statement made clear that the incident didn't impact their customer-facing operations. However, it should be noted that Diebold represents 35% of US ATM machine infrastructure and has a considerable presence in voting machines. The second incident that I noticed was, according to Variety magazine, so I guess we'll see how reliable that is, but a law firm, Grubman, Shire, Mazalius, and Sachs, experienced a ransomware attack using the newest development of ransomware, Reveal malware, and rather than simply knocking out the law firm temporarily, the ransomware are said to have stolen personal data from a laundry list of celebrity clients, about 750 gigabytes of personal correspondence, contract information, contact information. And this law firm represents people like Lady Gaga, Madonna, Bruce Springsteen, Mary J. Blige, and a few other high-profile celebrities. The third incident was from Austin, Texas, where the courts have shut down their website and servers in response to a serious information security breach. And according to a statement from the Office of the Courts Administration, the IT provider for appellate courts discovered the attack early hours of Saturday morning. I don't know if it was just lucky for me or either by blind chance or probably statistical certainty, that the 3 examples I've cited here, the first 3 that were returned in my Google search last night, supposedly represent highly secure environments: the banking and finance sector, legal, and public services, and thusly highlighting the continued prevalence of malware persistence, despite my assumption that these IT structures contain threat avoidance or threat detection or remediation capabilities. Now, I should caveat that statement with the fact that I've not really looked into any of these incidents with any scrutiny, and so probably shouldn't comment on the possible threat vector. I'm just making an assumption given the verticals and that some sort of preventative techniques should have been in use at least one of these companies. So this is a slide that anyone who's ever sat through a security presentation will be familiar. It's statistics and key points for me to highlight. And these threats and exploits are on the rise year on year. Organizations have to deal with these very real statistics and strategize around business continuity in the event that they themselves become compromised. The sheer weight of new vulnerabilities is scary enough, but in this slide, I'm focused on 2 statistics gained, or the theme of 2 statistics gained from 2 different sources: the CrowdStrike Global Threat Report for 2020 and the McAfee Cloud Adoption and Risk Report for 2019. So the first statistic that we see here is from CrowdStrike, and it highlights that malware-free attacks, as in those attacks that are conducted by advanced persistent threat actors, are gaining popularity, escalating from 40% in 2018 to 51% in 2019. And this trend towards malware-free attacks is accelerating, and North America bearing the brunt of most of that activity. Now, if we consider that, and the second statistics from the McAfee Cloud Adoption and Risk Report, I include this to emphasize the weight of potential manual, i.e. malware-free attacks in public cloud utility. That would be companies like AWS, GCP, and Azure. Infrastructure as a service. And this accounts for a significant portion of enterprise IT computing power, and misconfigurations continue to plague the security of this platform. The third statistic is from CrowdStrike again, and this deals with breakout time, which is a metric which measures the spread from adversaries' initial intrusion into the environment to when they achieve lateral movement across the victim's network towards their ultimate objective. So this metric is encouraging in a stance because it infers that defenders are able to take longer to respond to potential threats, but it also reflects a dramatic rise in e-crime attacks versus nation-state adversaries. E-crime can be perpetuated by relatively unskilled practitioners and thus doesn't really represent the potential for lateral movement, but lateral movement still occurs. And finally, again from the McAfee report, on average, the time to recover business operations after an unplanned downtime event is about 10 days. This, to me, highlights another concerning statistic in that enterprise IT business continuity planning is either entirely absent or it's inadequate to support the demands of modern hybrid cloud applications. So there's a new-ish, but not really, concept in security for 2020. It's under a label of zero trust security. I'm sure you've been familiar with this. NIST has a draft special publication, the 800-207 for zero trust architecture, which I encourage you all to read. And this proposal is for a new way to look at network security. It's rooted in a concept of traditional, otherwise known as old, network security concepts. So you see, for most companies, network security is based on a castle and moat concept. The physical analogy being your castle, i.e. the thing you want to protect against attack, is surrounded by protection by means of a deep and wide moat. There's only one way in and out of the castle over a drawbridge, which is heavily guarded, and anyone attempting entry would have to pass a rigorous security check. And when trust is established, you're free to roam around the castle. So if you apply this concept or this analogy to network security, the castle is your internal network, which supports your critical infrastructure. telephony, compute, storage, applications, file systems, etc. And the drawbridge and guards represent your edge point firewall and password challenge response system. So in this method, if an attack were to be able to penetrate this line of defense through, let's say, brute force methods, he's trusted inside the network and can begin taking down systems one by one. Now, I'd be hugely surprised if any organization still represented this type of security architecture, but ostensibly, the landscape hasn't really changed. We've just introduced new and more sophisticated technologies in order to try and prevent the myriad of attack vectors that exist today. These layers of traditional security to support the network protections, which themselves have evolved to include technologies like subnetting, access control lists, VLANs, and firewall packet inspection, IDS, IPS. So you have technologies like antivirus applications, now endpoint protection suites. I can include in this line of defense any other software used to detect and isolate and respond to malware like DLP. We've established more robust identity access management controls with authentication and authorization. We've also established better encryption technologies, data at rest encryption, data in transit, data in use, active memory, and cache. And so the reason why this tactic of layered defense is sometimes ineffective is because it's rooted in concepts belabored by platform-centric approach to security. And if you think about it, the evolution of security technologies has to have been reliant on the support infrastructure in use in the data center from yesterday. Networking only evolved because virtualization changed the way we utilize compute resources. So technology was forced to support expansive IP address schema. Firewall whitelist became a hindrance to optimization if used to measure packets between communicating user virtual machines and applications because of hairpinning, which I'll discuss shortly. Evolving concepts based on yesterday's problems is sadly the way many of these products have had to maintain profitability. They're reliant on improving capabilities through feature sprawl and addressing challenges introduced by platform constraints that have effectively been unchanged in 20 years. Oh, someone just blew their nose. Rarely do companies get this opportunity to reinvent the way they should be establishing security across modern day applications. And this is really where Zero Trust is attempting to bridge the gap. So if you and I were to design security concepts for today's applications, how would we do it? Well, first we can abstract ourselves from the limitations of the underlying platform. I mentioned before this potential for hairpinning traffic, and this is where inter-application communication, if it were to be inspected or filtered by a firewall, has to first traverse the network in a north-south direction. This is inefficient in a virtual data center environment, and it introduces latency. Firewalls can now be deployed as virtual appliances and dispersed throughout the environment. So network latency due to hairpinning of communication of the traffic is no longer an issue. So if we were to consider how we would like to apply security to applications today, we could explore their nature in cloud environments. Since cloud is as we have been discussing for the last 10 years, is the future of enterprise IT. So new applications are ephemeral, as in lasting only a very short time. Virtual machines or containerized applications can be destroyed and spun up as microservices immediately, or by automatic orchestration. So this provides the benefit of cost reduction in a cloud subscription-based consumption method. You're paying for what you use, so you want to use what you use for a very short period of time. There's also the benefit of being able to scale operations quickly up and down to meet the seasonal demands of your application. There can be dynamically allocated address spaces, either through DHCP or some type of IPAM allocation. So a different method of tracking these machines is necessary. Some kind of automatically assigned protection policy would be ideal in these situations. Identifying the critical assets through tagging would be more suitable and easier to set up and manage than a complicated IP whitelisting. Visualization of the interdependencies between these applications also has to be considered. These new apps can exist across infrastructures, spanning both your on-premise infrastructure and public cloud AWS, GCP, or Azure instances. So seeing the relationships between web servers, application servers, APIs, databases has to be near real time and represent clearly the interdependencies so as to be able to address security misconfigurations more simply. In essence, the new security model should be application-centric over platform-centric, or limited by platform-centric ideals. So I understand there are a multitude of issues that security engineers face, and I've tried to distill an entire career into what I see as the source for many of them. So, as I alluded to earlier, complexity is a security issue. Complexity in configuration, as I mentioned, it breeds a state of something I'd like to call perpetual legacy, which I will get into again shortly. You're never really able to innovate or adopt advanced security practices like OSINT because the day-to-day mundanity, the activities that you're driven towards doing are just so prevalent. There's an issue of visibility into the whole stack. Concurrently, well, it's predominantly driven by a multitude of management interfaces, but it's also the interruptibility or lack thereof between these interfaces. These vendors are often innovating by introducing forward-thinking technologies like machine learning, but they rarely get to have the opportunity to have input from across the entire data center infrastructure stack. And even in a world of cloud misconfigurations, early on, they weren't part of the notification workflow. The onus was on the customer to make sure that they ensured the security of their infrastructure on their platform. Ideally, a good visualization tool provides clear and actionable insights, and it doesn't contribute to alert fatigue. And lastly, I see an issue with the ability to perform business continuity. Disaster recovery technologies are often third-party tools which either help translate data types and architectures from your on-premise data center to either the t-shirt sizes that are available in public cloud, or even just a complete replica of your current infrastructure in a different geography. So it's complicated, it's laborious, it's costly. It's not intrinsic or intelligent or in a sense, it doesn't work like technologies in the commercial space work, considering your iPhone, for example. iCloud technology allows the backup of your phones and contacts without you having to do very much. And business continuity and DR concepts should be just as simple. Closer to home as well, even within the data center itself, there are issues with confirming the integrity of data and reacting to either data degradation or data corruption. That's especially prevalent on some legacy platforms. So I was watching Shazam with my little boy recently, and not to spoil the movie or anything, but there were two characters, Freddie and Billy, and they talk about which superpowers they'd prefer, invisibility or flight. The thought experiment being that invisibility is kind of a useless power in itself, and it only confers power over other people and social situations, whereas flight conveys little power in social situations or other people, but is intrinsically useful. And therefore, the response can lead to insight as to the respondent's subliminal preference for good or evil. Still, I thought it would make a nice challenge for myself to try and apply these concepts to data center security challenges. So the problem with new technologies is a skills gap challenge. Resources are limited, and adoption of new capabilities, however effective, come at a cost. So the impact of the business resources is that of time to assess these technologies, time against your business objectives, time to prove the concept, time to train staff or hire new staff, time to operate and integrate and transition. Even after all this time, the inherent complexity of adopting new technologies creates an environment rife with potential vulnerabilities which hackers live to exploit to their full advantage. So new technologies should meet these challenges by providing a delightful customer experience, utilizing automation in many cases to meet the run-of-the-mill security challenges. This is exactly what George mentioned earlier. When it comes to the superhero question of what superpower to choose, invisibility or flight, in technology adoption, we can choose both. When I talk about IT and security invisibility, I'm describing an environment of self-configuration and self-automation, self-healing, using robust frameworks that exist today to achieve audit-ready compliance from the day the physical boxes are installed in the data center. So a private cloud that needs to meet these challenges of securing applications easily, but can also be operated by a generalist, not a specialist, within weeks of training and not months, years of training. So this allows for the mitigation of potential misconfiguration errors, which are so prevalent in IT today. Flight can be thought of as the ability to drive and support business goals without the impediment of physical infrastructure. So you want to move to a containerized application method using Kubernetes or deploying to a cloud of your choosing. This shouldn't require a lift and shift of equipment in the data center. It should really be a simple, intuitive interface and part of the operational dashboard that's familiar with your IT staff. And dynamic security policies being able to apply simply by tagging a machine with a category. And the effects of network isolation, backup, and recovery are then applied to that machine just by the simple category tag, whilst providing clear visibility of its communication pathways and associated services. So, to address the space, if you're not familiar with what Nutanix does, we invented the concepts of something called hyperconverged infrastructure and web scale engineering. Effectively, some of the back-end engineers that used to work at Google decided to commoditize the cloud computing space. And if you're familiar with data center technologies, they've collapsed this stack of services into a single two-use chassis platform with directly attached storage, and then virtualized a lot of the components within the data center. So when we went about doing this, obviously the concept of security in this platform was an issue, because we had an issue of the hypervisor, which is the abstraction layer that allows you to run multiple machines on a single infrastructure. And there was issues with how the bare metal components communicate from software to hardware. We had issues of hardening the physical and virtual server machines themselves, making sure that they get proper resource allocation and proper confinement so that VMs can only speak to one another unless expressly permitted to do so. There were issues in the networking layer, and you have those individual components, those individual requirements for separating those LAN segments and creating and separating subnets using VLAN ID tags. And so all those components play into the overall aspect of achieving proper isolation. We had issues on the storage layer, and not the traditional levels of differing protocols, but then the new innovative technologies that we were bringing to bear with things like a distributed file system. And then finally, we had user interfaces and the management components for each and every one of those individual pieces. Now, if you're familiar with these environments, you would be familiar with the practice of trying to update firmware and BIOSes and OS versions across this stack, hardening each one of them individually, and then if something breaks, being told by support by one of the myriad of technology vendors that exist in your data center to roll things back that you've already deployed. This is where the concept of perpetual legacy came in for us, where it legitimately can take 6 to 9 months to go through accreditation and IA processes in order to develop and deploy new technologies. And this is really where the concept of being able to harden the platform automatically, intrinsically, from day one and heal any deviations with automation came about. Now, when I was on the customer side and I'm assessing various technologies, as I'm sure some of you are today, I never once asked those technologies the processes by which they secured their platform. It's now actually common practice to at least ask the question in some type of cloud assessment survey whether or not they have a security development lifecycle process. So this is indeed a step forward. I think there is benefit to have an idea of what that process may look like, making sure that they do things like static code analysis and vulnerability scanning, penetration testing, things of that, making sure that they use some type of agile delivery lifecycle method that would permit them to iterate quickly and reduce the capacity for zero-day threats to take hold in their environment. Now, if you are in the process of working in data centers, the process of system and security hardening would be familiar with you. It's obviously much more nuanced than the 6 items that I share on the screen with you, but the goal is always the same. It's attempting to prevent the possibility of executing vulnerable code by restricting the methods of being able to access certain systems. This is, again, a process which, if done manually, has the potential to introduce misconfigurations, errors, and those errors could be extrapolated if that is used as a gold image across the environment. So ensuring that some type of platform has intrinsic security built in by the use of STIGs. Now, STIG stands for Security Technical Implementation Guides. I'm sure you know that. Originally a manual process for system hardening. Nutanix introduced a check content field, which is written in XCCDF XML formatted language back in 2011 when we created the platform. And we decided to align our own STIG to the NIST Special Publication 853 for federal information systems. And that helps satisfy some requirements for some of our DoD space customers. Effectively, all we're trying to do here is achieve a baseline set of robust security controls across the entire infrastructure or system security stack. So when we considered the traditional method of deployment, you've got installation, you have a process of attributing hardening guides to the tune of several hundred pages and hundreds of thousands of dollars of operational expense and overhead from your own organization. Documenting that baseline, going through accreditation. It's not uncommon for this process to take months. In an automated environment, we can measure this process in a matter of days. And being able to heal from deviations to that baseline that we've set is also, I would argue, a necessary requirement in the age of ever-expanding IT. So at Nutanix, we consider the host security side of it or the system security side of it with things like intrinsic hardening and self-automation and in ensuring data integrity, and whilst maintaining a development lifecycle which has security at the forefront and it is considered security in all developments. As well as the data security side, the ability to give customers and modern applications application-centric security, where security policies are defined on the virtual machines themselves, regardless of where they sit. So very briefly, a shameless plug for ZBeam. Now, Nutanix is a vast data center technology company, a cloud operating system. We have a small tool available in AWS called ZBeam. It's excellent at conforming to the various compliance standards, which is usually difficult at the best of times, especially across various cloud platforms, both public and private. And it can make the task fairly unsurmountable. So ZBeam is a software as a service dashboard, which gives public and private cloud the ability to, I guess, check for blatant misconfigurations across any of your useful infrastructure types. So if you're using AWS and Azure, and you're using perhaps Nutanix in your own data center, you can measure the potential misconfigurations for all your virtual hardware, as well as cost governance. So with the ability to do departmental chargebacks and forecasting, and even going to make recommendations on cloud spend optimization. The reason I bring it up is because this is, I think it won one of the security awards in AWS for last year and the year before that. And it's not solely a Nutanix product. Well, it is a Nutanix product, but it's not solely a Nutanix-centric product in that you'll get utilization from it, especially if you're doing anything in PCI, HIPAA, or CIS across any of your cloud environments. We also have an initiative at Nutanix called Project Victory, which is the hiring, retraining, and supporting of veterans at Nutanix. And some details for it here, and I can shoot you those individually or as part of this PowerPoint presentation at the end. So I just want to thank you again for your time. I hope you got something out of it today, and I'm happy to answer questions.